In this lesson, we build an intuitive understanding of the concept of a limit using clear graphs and animations. When we say, the limit as x approaches of f of x equals L, we mean that when x gets closer and closer to it from both sides, the y values of f of x get closer and closer to the single number L. Let's start with a classic example. Consider the function f of x equals x squared minus 1 over x minus 1, which simplifies to x plus 1. For every x not equal to 1, we'll graph the simplified version, y equals x plus 1, but show a hole at x equals 1, y equals 2. Watch the moving point approach, x equals 1 from the left. Notice the y value approaches 2. Now from the right side, again the y value approaches 2. The limit as x approaches 1 of f of x is 2, even if f of x is not defined at 1. To make this visual, let's draw a horizontal band around L equals 2. Think of its half thickness as epsilon. If I choose epsilon equals 0.5, I can find a vertical band around x equals 1 of half width delta, so that whenever x stays inside that vertical band, the curve's y value stays inside the horizontal band. For the line y equals x plus 1, choosing delta equal to 0.5 works. This is the core idea. X close to implies f of x close to L. Next, one-sided limits and a jump. Consider a piecewise graph, where for x less than 0, y equals 1, and for x greater than or equal to 0, y equals 3. As x approaches 0 from the left, the y value approaches 1. As x approaches 0 from the right, the y value approaches 3. Because the left-hand limit and the right-hand limit are different, the limit as x approaches 0 does not exist. Finally, infinite limits. Consider y equals 1 over x minus 2. As x approaches 2 from the left, the y values dive down to negative infinity. As x approaches 2 from the right, the y values shoot up to positive infinity. We say the limit is infinite near the vertical asymptote x equals 2. Summary. 1. The limit describes what y approaches as x gets close to a. 2. The limit can exist even when the function is not defined at that point. 3. If left and right approaches disagree, the limit does not exist. For near vertical asymptotes, limits can be infinite